Okay, you have some references here, some documents that you can, some books that you can also download and read. Okay. All right, so based on this, do we have any questions, any worries? Somebody is saying they had just an introduction. Introduction to what? To Blessed Gam. Is it Blessed? Who said this? Hello? Hello, Blessed.
Yes, sir.
Yes, so you were saying something.
We just had.
Sorry, I can't hear you very well. Can you repeat?
So we just had an introduction to computer programming.
Okay. Last year, right? So last year you had a course, Introduction to Computer Programming, right? And you also had a course with me. You had a course with me that was it Introduction to Computer Science, Computer Science 1, something like that?
Yes,
Computer Science 2.
Yeah, and in that course, I also we presented the C programming language also, right?
Yes, sir.
Apart from that course, did you have another one on programming?
No, sir.
It's only that one, sir.
Okay, then it is not too bad because I know what I did. I know what we did together, so you already have some basic knowledge, and that is good for this course. That is good for algorithms and data structure. So like Chiabi was saying, it is important that you connect with your names. When you connect, you write your name so that we know the person who is there. Okay. And you put your full names. When I see Gina, when I see Ivo, I don't know who, you need to write at least 2 of your names. I see another person is just me. Okay. You need to put your names because this is how the attendance will be taken. There is no magic. If your name does not appear clearly here, you will not expect Chabi to know that you are the one. So, and for me to also know that you are the one. So you should make sure you put your names correctly. I think it's possible to do that. So try to put your names as they are. Blazy is nobody. It's no name. Ivo is no name. Me is no name. So it is important because we don't want any complaints. Huh? It is important for us for me to know if I'm addressing you, I know that this is the person I'm addressing and not some random user. And also it is important because we need to know that the people with whom we are in the meeting, we should not have strangers for our own safety. Huh? All right, so if there is no other question regarding the outline, we will start straight, or we will begin directly with what we have to do today. You can always leave your comments. There is a comment. Yeah, you can always leave your comments in the chat and I can read and respond. Okay. So any questions regarding how the lectures shall be done, the assignments, the evaluation, the attendance, the participation, any worries, any particular worries, the timing of the lectures, maybe 9 p.m. is not good, maybe others will prefer 4 a.m. or 12 midnight, or if you have particular worries, you can raise now. So let's look at it before we proceed. You go ahead, right?
Yes, sir.
All right. I'm receiving a notification that the meeting will end in 10 minutes. So if it ends, you should start the meeting with the same link, right? We'll join with the same link. Okay. So for this week or for today, we are supposed to look at introduction to algorithms and to Java programming. Okay, so it is an introductory lesson to what algorithms are and also to Java programming. From next week, I will be expecting you to already have your NetBeans installed in your computers and to already do the few assignments that I'm going to give you and to submit online on time. Okay, so today we'll look at we'll have an introduction. We'll look at what objects are. We'll also understand what classes are. We'll look at the concept of inheritance, interface, package, and then object-oriented programming. Okay, because these concepts are going to help us. Once we understand these concepts, we can now dive into data structures. We can now dive into algorithms, because we'll be writing algorithms only if we understand already maybe some basic concepts on programming language or on computer programming in Java, because we will use the programming language to actually implement some of the algorithms. Okay. So now we want to look at what an algorithm is. For you to be able to solve a particular problem, you need to outline the stages or the steps that are involved in solving that problem. You will need to indicate what are the elements that you need to as the input or the resources that you are going to need. Once you have the resources that you are going to need, you are going to look at what are the different computations or the processing or the transformation that you will need to make on those resources to produce the required output. Okay, so that's basically what is involved in every production. You need to understand, what do you need to produce? What you need to produce is the output. Then what are the things that you need to produce this thing that you want to produce? Those things are the inputs. And then you will now look at how are you going to transform this input to give you the output. And that is now the processing. So you see that an algorithm will be what? Will be a finite or a well-ordered collection of simple and computable instructions for performing a particular task. Okay. A well-ordered collection of simple and computable instructions for performing a particular task over a given period of time. Meaning what? Meaning an algorithm should be simple, it should be well-ordered, and then it should work for a given period of time. It should not be forever, okay? And then, like we said, you will need to understand what is the problem that you want to solve. What do you need at the output? When you have what you need at the output, you will now look at what are the things that you need at the input. What are the resources that you need or the raw materials that you need in order to have this output? Once you have the raw material, you will now look at what are the necessary or what is the necessary transformation that you need to perform on these inputs in order to obtain the output. So that is basically what an algorithm is. If you want to write a program to maybe calculate the GPA of a student, that is a task, okay? The output is that you want to have the GPA of a student. Now, for you to have the GPA, what are the elements that you need at the input? Maybe you need the marks for all her subjects, or maybe you need the averages, or whatever you need in order to have the GPA. You are going to determine it, and once you determine it, you will now look at the logic, the processing that you need to do with this input in order to obtain the GPA. Maybe you need to take the average of all the inputs, or you need to take the square root of all the inputs, or you need to do apply some several functions on the input in order to obtain this output. It is based on, it depends on you, and it is the processing part of it. Okay. Somebody speaking?
Okay.
Bernard, do you have something to say?
Okay.
Bernard. Okay, I urge you to always be attentive. Even if the lectures are online, you need to be attentive and focus on what we are doing. Inject, is inject there?
Yeah,
I'm there.
Okay. All right. So we are just explaining the concept of computer algorithms. So algorithms are applied in every problem that you want the computer to solve. And when we say the instructions should be computable, there should be things that are feasible that can be done with a computer. You will not ask the computer alone to crack a stone, for example. For the computer to crack a stone, maybe you will need some other physical or mechanical tools to do this. It will need to command some mechanical tools to do this. So you need to be sure that what you want, you're asking the computer to do is actually computable. The kind of instructions you are asking the computer to execute are computable. They are realizable, okay? Now let's quickly look at some characteristics of algorithms. When you write your algorithms, you should ensure that they are well ordered, okay? The steps are well ordered and that they are simple. Simple means they are unambiguous and that they are effectively computable. They are effectively computable, okay? And that you have some input. You need to identify the input and you need to identify the output. You should not write an algorithm that is not giving you any result. If the algorithm is not giving you any result, it is not solving your problem, okay? And then the algorithm should be finite. It means the steps should be, it should terminate after a finite number of steps. It should not be for forever. It should be feasible, means the resources that you need should be resources that are feasible. Feasibility does not necessarily mean technical feasibility. You also need to look at the financial feasibility. You cannot be writing you cannot be proposing an algorithm that will need maybe to solve a problem of 10,000, and you will need resources that will cost a million francs. That will cost a million francs, and you are to solve a problem of 10,000. So you need to look at how feasible this algorithm is financially, technically, and all sorts of feasibilities that you can have. So that's why you always need to do a feasibility study to see that this is actually feasible. Then it should be independent of a programming language. So normally when you write your program, it should be able to be run on any programming language. Either it is in